Good day, students. It's always great to learn together. Let's take a look at what we'll explore today. In our last lesson, we learned about placing value of numbers and multiplication of numbers greater than 1 using logarithms. In today's lesson, we will focus on division of numbers greater than 1 using logarithms. We will also learn about logarithms of numbers less than 1. Let's dive in to see what's next. Now, let's talk about division of numbers greater than 1 using logarithms. Recall that, to multiply numbers, we add their given logarithms. To divide numbers, we simply subtract one logarithm from the other. Let us study the example below. Example 1. Evaluate 286.3 divided by 17.08 using logarithm tables. Let us get our logarithm table. Let's break this down, step by step. Solution. Step 1. We will draw a table and insert the numbers we are evaluating in the first column, just as we did in our last lesson. Then, we will first get our characteristic before we solve for the mantissa. Since 286 is between 100 and 1000, the characteristic is 2. We will write 2 with a decimal point, then solve for the mantissa. Remember the process of looking for the mantissa of a number in the log table. You can refer back to lesson 1 for the steps if needed. Now, let's solve for the mantissa of 286.3. To get the mantissa, we will read from tables. Log 28 under column 6. Then we will add the mean difference of 3 in the row, which is 5. This gives us 4564 plus 5. Our answer is 4569. We will do the same thing for the second number. 17 is between 10 and 100, so the characteristic is 1. We will write 1 and solve for the mantissa. To get the mantissa, we will read from tables. Log 17 under column 0. We will also add the mean difference of 8 in the same row, which is 20. This gives us 2304 plus 20. Our answer is 2324. Let us now subtract the two results. 9 minus 4 is equal to 5. 6 minus 2 is equal to 4. 5 minus 3 is equal to 2. 4 minus 2 is equal to 2. 2 minus 1 is equal to 1. Our answer for the first step is 1.2245. Let's now go to the next step. For the second step, we will get our antilog table. Let us draw another table and insert the answer from step 1. We will now read from tables, antilog of 22 under column 4. And add the mean difference of 5 in the row, which is 2. This gives us 1675 plus 2. Our answer is 1677. The characteristic of the log 1 shows the index value of 10, which multiplies the antilog to give the answer. That is 1.677 times 10 raised to power 1 equal to 16.77. Therefore, 286.3 divided by 17.08 equal to 16.77. Next, we will look at logarithms of numbers less than 1. We know that counting numbers starts from 1 and are positive whole numbers. The opposite of positive numbers are negative numbers, which are usually shown by a minus sign. We learnt in the last lesson that the place value of numbers greater than 1 are expressed using powers of 10. Now, let's study the place value table of the numbers below. From the above, the place value of numbers greater than 1 are 10, 100, 1000, etc. And less than 1 are 1 over 10, 1 over 100, 1 over 1000, etc. Numbers less than 1 can be written in decimal form as 0.1, 0.01, and 0.001, etc. We can identify the place value of the numbers when they are expressed in standard form. For numbers less than 1, they are expressed in negative indices. For instance, 0.472 equal to 4.72 times 10 raised to power minus 1. Now, let's solve an example to see how this works. Example 1. Find the logarithm of 0.0065. Let's take it a step at a time. Solution. Step 1. We will express 0.0065 in standard form. This becomes 6.5 multiplied by 10. To determine the power of 10, count the number of zeros after the decimal point and before the first non-zero digit. This count is converted into a negative number. So let's count. 1, 2, 3. We will stop here, because 6 is the first non-zero digit after the decimal point. So, the base of 10 is minus 3. For step 2, we will use log table to find the logarithm of 0.0065, which is equal to log 6.5 multiplied by 10 raised to power minus 3. Let's apply the first law of indices, which is log A times B is equal to log A plus B. So we write equal to log 6.5 plus minus 3. Let's get the logarithm of 6.5 before we proceed. The integer 6 is between 1 and 10. So the characteristic is 0. Refer to the number digit table in lesson 1 for guidance. We will write down the characteristic and solve for the mantissa. To get the mantissa, we will check the logarithm of 65 under column 0 in the logarithm table, which is 8129. So the logarithm of 6.5 is 0.8129. Now, let's proceed. Equal to 0.8129 plus minus 3. Let's now rearrange the terms to make it clearer. Equal to minus 3 plus 0.8129, which is equal to minus 3.8129. This negative index, minus 3, should be written as bar 3.8129. So, log 0.0065 equal to bar 3.8129. Assignment. Write down the following assignment and try solving them yourself. Take it one step at a time. Remember, each attempt is a step forward. In conclusion, we have learned how to divide numbers greater than 1 using logarithms. We also learned how to find logarithms of numbers less than 1. Watch out for our next lesson, where we will learn about addition of numbers less than 1 in logarithm. Always remember, learning is a journey. See you in the next lesson. Thanks and goodbye.